try to conduct half and full today if we have much time. Okay, and better one thing I can do, I can give you. Okay, I will try. Anyway, so half-wave rectification. Listen, this was the diode. P and N. Okay. So let's draw the diagram as well here.
হ্যাঁ এবার হচ্ছে অন্যকে কথা না বলে ভিডিও ইয়েটা ভালো হবে
diagram, okay? So draw the circuit diagram. For half-wave, this is half-wave rectification. Listen, think about, this is exactly the application of the diode. And if you think about this is the power supply of a computer. Here, the first process that has been like started with this is the rectification. Using that diode, the characteristics we have just like came through in the last experiment. Using that diode, they have just rectified it. So one of the rectification processes is the half wave. Why it is called half wave? Listen. If you think about a full cycle, this is a full alternating AC cycle. So the one half of that full cycle is can be drawn at the output. Like it will get at the output only one half, and this portion will be absent at the output. This positive portion will be absent, and this negative portion. Sorry, the positive portion will be present, and this negative portion will be absent. That is why it is called half-wave rectification. Okay. Why? Okay. Listen. So this is the transformer. Here we have 220 volt AC. Okay, I mean this line voltage. So this 220 AC voltage will be stepped down, because if we directly connect this 220 voltage to this diode will burn out. Okay, because it is too high voltage. We need 5 to 10 volt. You can think about 5 volt or 9 volt or 10 volt. Okay, we'll work with the 9 volt like this, okay, or 5 volt. So that means this transformer will step down this 220 volt into 9 volt. You understand? Okay. So listen, few things you need to come across. First is frequency. What the frequency is? Frequency is like, okay, this is a full cycle. One cycle, okay? So this things is the time, maybe 0 to 1 second. So now this is one full cycle. So if in 1 second one full cycle is there, then it is called 1 hertz. So if there is some 10 full cycle here in 1 second, like this, then it will be called 10 hertz. So the current, the voltage we have here has got 50 hertz. What does this mean? This means 50 times in 1 second. There are 50 full cycle in 1 second. Okay? There are around 50 full cycle in 1 second. That is why we call this line as 50 hertz. You know, this line is switching on and off for 50 times in each second. But we cannot see it. We can see only 10 times. If there is a less than 10 times in a second, that's what we can sense by our optic nerve. But if it is more than 10, human brain cannot signify that. So exactly here 50 times everything is switching on and off. So this diode will conduct for 50 times and will not conduct for 50 times, because in one full cycle, during positive half cycle, this diode will be forward biased, and during negative half cycle it will be reverse biased. So in each second 50 times, if we connect this power with the diode, we will see 50 times a second this diode will be switched on and switched off. Okay, got it? Okay. So let us make we will now see what is happening here. What we are going to get at output. If we apply this signal here, okay, this signal will ultimately come from this AC. This is the AC. Okay, this is how the AC looks like. Okay, I will show you the AC first, and then I will make this connection, and then I will take the output from this resistor. Okay, output we will take the output across the resistor. we have taken the output at the last experiment across the diode VF, but now the diode is free. The output will be taken from the resistor, across the resistor. You understand?
Yes.
Okay. And then, so if we apply this AC signal input, what is happening? During positive half cycle of the AC, this is the positive, this is the negative. When there is a positive, during this positive half cycle, this positive will repel, and then this barrier will be eliminated and the diode will conduct. Okay? That means what? Which will allow, as the diode will be short. So this diode will, now the diode will allow this portion to pass through. Because this is the total time, maybe it is at 1 second. Think about this is 1 hertz. So 1 second, that means what? From 0 to 0.5 second, this one will come, this positive half second. And then in the next 0.5 second, this half will come. So during this half, the diode will be forward biased and it will be short. Okay? So as the diode will be forward biased and short, it will allow this portion to pass through. That means what? At the output we will get this positive portion. Everybody understand? Okay, fine. So during negative half cycle, the negative will come here. I mean here. What will happen? This positive will get attacked, so the barrier will increase. So it will be open now, like this. So there is no connection. That means what? This negative portion will not be allowed to pass through because it is open. That means we will see no sign here. It will be nothing. Again, next positive half cycle, we will get it. And next negative half cycle, absent.
No. Yes, sir.
What makes negative? So there is how in each second we will see 50 positive is there, but there is no negative. So that's what we will get from the half wave rectification. Okay. So let's talk about full wave rectification. Both will conduct. Okay. The same arrangement. There is not much change. For full wave rectification, there are two types. One is full wave center tap, another is full wave bridge rectifier. Center tap is this. For center tap rectification, there is additional wire which will be taken from the center of the transformer. This is the center. Okay. So for center tap transformer, I mean rectification process. And for bridge, the center terminal will not be taken. This is only the difference, but the procedure is same. Okay, what is the difference between half wave and full wave? In the full wave, we will get this negative half cycle and out as positive. That is only the difference. What is happening? The efficiency is increased here, because earlier the efficiency was half. This was the full power, but we had half power previously up to this. But now for full wave rectification, we will get the total full cycle at the output, but in this form, same direction. No, we will add one more diode. Full wave for full wave we will have to add one more diode. Okay. So what do you suggest me to conduct only one experiment or to conduct both?
One experiment.
One.
Should has it been too much pressure for you? No. Do you think it has been much pressure for you? If you think, then I'm just can like continue with this, and I can start conducting. Which one you suggest? To conduct both or to conduct only one at both? Okay. Some are remaining stop, which means they don't have positive mode. Anyway, how much time left?
Time, sir, আছে
10 minutes left only.
8 minutes.
Okay, anyway, time has also got variation. Anyway, so 10 minutes. Anyway, listen. So for full wave, we will add one more diode here. Okay, and then we will. Okay, there will be a resistor, but this resistor will be connected before. Before this resistor is connected, this two terminal will be short, and then now this is the full wave rectification. We have used another diode which will which will take this negative half cycle into the output. Earlier there has been only one diode, and that diode used to take only this positive half cycle. Negative half cycle was absent. But this time for full wave, this diode will take this portion, and that diode will take this portion at the output. So that is how we will get both of the positive and negative half cycle at the output. I think it has been somewhat tough for you to adapt both. Okay, anyway, so we will just conduct only one experiment. Okay, I'm just raising this and making one experiment. I don't want to bother you with this. You are not a departmental engineer, you are non-departmental engineer, so I don't like to push some pressure to you. What is that? That was the resistor. Okay, so let's start. So you can switch it off now because we move this to this, then you will start again from the beginning. This will help you because this was a part of conception. Now it is the practical. এখন প্র্যাকটিক্যালটা নেওয়ার জন্য আপনি এইটা নিয়ে এখানে আসেন, তাহলে আপনি সুন্দরভাবে এটা বুঝবেন। এইটা নিয়ে ঠিক আছে, আর আপনারা ওইখান থেকেই কারণ আমরা নিজেরা তো দেখতেছি।
দেখি
বলেছি বোঝা যাবে না, বাসায় নিজে শুনলে বুঝতে পারবেন না। বাংলায় বলা যায় না, বাংলায় বললে আপনারা দেখা যাচ্ছে এটা ইউটিউবে ছাড়ে, এটাকে ওটা সবাই ইউটিউবে ছাড়ছে, তো বাংলায় বলতে গেলে এটা আমার চাকরি নিয়ে টানাটানি। আগের এক্সপেরিমেন্টগুলো আসলে হ্যাঁ অনেকটা একই, ওগুলো আপনারা ইউটিউবে সার্চ দিলে পাবেন, কিন্তু ডাউনলোড করতে পারবেন। ওকে, সুইচ অন দ্য পাওয়ার। স্টার্ট করেন না, ওয়েট করেন।